Welcome back, ladies and gentlemen. Time for a new session, time for a new topic. From coffee, which was the topic of our two previous sessions, now we move to another product, similar product, to tea. In the last 20 years, there has been a shift from traditional black tea towards flavored and herbal products. Producers had to react to this shift in terms of products, but also in terms of packaging. Stefano Fiordalisi, the sales manager at the Tea&Herbs division of EMA, is connected with us, and he is going to tell us how their technology has responded to this new requirement. So good morning, Stefano.
Good morning, Pietro. Thanks for introducing me. Hi, everyone there. As you've mentioned, the new and more sophisticated blends addressing not only a new taste profile from the consumer, but also the aesthetics and sensorial requirements of the market, have created a new segment that we call high-end or gourmet, where the bag is actually designed to show its very attractive content. Another important driver for this was the intention to replicate the experience of having a nice cup of tea from loose tea leaves into a tea bag. The other main point is that in the early days of the millennium, we had actually an increase in demand for sustainability and recyclability, which has driven into the development of new materials, PLA-based. So all of this translates into this piece of equipment here. In any case, the first thing I would like to show is the tea bag. What we produce here, which is actually a nice envelope with a very nice product with PLA woven, transparent, fully transparent, with obviously a very attractive blend inside. Okay, so now we would like to take a look at the workflow of the machine. And so let's start from the left-hand side, where we have actually the material reels for all the different materials. So we have the web, the filter web, the tag, and the thread. All of this obviously consists of the naked bag I just showed to you, and this is basically all based on ultrasonic sealing, because this kind of material requires that. So we'll see, just going ahead with the workflow of the machine, its sealing technology, which is the most traditional one, only in the last section where we seal the envelope. Now, I think we should go through the workflow right now. So we would start with a section where we have the tag unwinding. And this comes to an area where we cut the tag and we actually move the tag 2 at a time on the first wheel, the first ultrasonic sealing unit, where the tag is sealed to the thread. The thread is prepared by a layout device, and then in the bottom section, we seal the thread to the tag. Then we have an area where we got the scissors to cut the thread, and then from the thread and tag all together, we are switching to the next station, which is the one where the filter web gets sealed to thread and tag. Here we have a combination of different seals, what we call light and strong seal due to the usability of the bag, because obviously you want to facilitate the usage from the consumer to unwind the bag, and then obviously be safe when you dunk the bag into the beverage, because obviously you have to hang it with no major problems. Okay, just coming back to the technology, once we've just completed the seal, we just go through all the different rolls to what we call a a folding section, and where we form the tube. The tube is formed, and then a longitudinal seal takes place, where we now have a tube. Then the next point is we drop the product into the bag. Now, this is coming from the most sophisticated and I would say also challenging part of the machine, which is the dosing head, where we designed and patented for this specific project to keep it very compact. It consists of a feeding device which drives the product from the hopper into the upper bowl of the dosing head. Some rotating pipes drives this into the loading cell. This is basically 10 stations with 2 scales each. One scale is dedicated to the nominal weight. The second scale is for fine adjustment purposes in terms of using a vibration damping software, also patented by EMA. Once we are in the 10 weighing cells, of course, we have to then interface with a buffering, which is what we call a racetrack, which is an intermediate section where every 2 stations from the dosing head will fill 2 stations of the racetrack. The racetrack will then bring the product into the area where it gets dropped by an air blow, and then we are back basically into the bag. The bag then needs to be sealed and cut by the 2 sonotrode. You see there, they also incorporate a rotating knife. Then a robotic arm picks up the bag and then brings it onto the conveyor. And then we have obviously individual bags, naked bags. These bags are taken by the conveyor all the way through to the envelope station. As you can see, the envelope is coming from the reel here, gets unwound, comes up, gets folded, pre-folded, and then rotating arm 90 degrees will bring the bag into the envelope. Then we seal the envelope. Like we said, this is heat sealing, not ultrasonic sealing. And this is basically done in one single operation, so it's continuous seal profile. It's a 3-side seal. Now, moving ahead, we have the cutting unit of the envelope. And then we come to that pickup robot there called the Delta robot, which accomplishes actually 3 main functions. Number 1 is to drop the bag into the stacking conveyor, the stacking container, I would say, because here we are interfaced with an integrated cartoning unit. The next point is potentially, if necessary, a single envelope rejection, which will then be driven into this chute, front chute. And the last function would be what we call top tail. You may see that basically the pickup robot takes every second envelope and rotates it by 180 degrees in order to compact the stack. So in general, let's say that where we are at the Delta robot station, we could have other options, because this is a market which is very much versatile. So you need to have modularity. So this means that we could come out of the machine with another solution, which is maybe bringing these envelopes to a pouch maker or a doy bag maker, something like that, if needed. Like we said, this is a different story. We have a fully integrated solution with a cartoner. So the box comes from that magazine. It's a pre-glued blank, which gets erected, glued, then formed and then sent through the carousel to the stacking station. So basically, we have that stacking container coming down, releasing the stack inside the box. Then the box gets to the next station on the carousel, to the lid closing unit, which we see on that side of the machine. And this is also very important because right now there's a huge demand for what we call tamper evident box. So with using no plastic, no overwrap on the outside. And then it can come up with obviously a conveyor belt and can be also automatically weighed by an integrated check weigher.
Stefano, thank you very much for this accurate description of this quite impressive machine. We know that the shape of the bag is a factor of success. So can this machine handle both shapes, I mean pyramid and pillow bags?
Yes, it can. It's actually one of the features of the machine. And now I would like to use as a tool a video where we show the changeover between the actual configuration from pillow bag into pyramid bag. Please.
Quite an impressive video, I would say. Stefano, some pricey and special blends require a particularly gentle handling. So how do you or does your machine cope with the product degradation?
Yeah, well, for this purpose, I would take advantage of another video showing actually a top view of the doser. So please, if possible. So as you can see, from the hopper, the product is conveyed into that vibrating feeder on the top end, and this is gently taking the product into the upper bowl. So there's no touching with any mechanical part, and the upper bowl then distributes to the rotating pipes. There's no scraper there, so no degradation can take place.
Okay, thank you very much. In the meantime, we have received a couple of questions from our viewers at home. So the first one, what is the layout impact on a medium-sized factory?
Well, it's actually minor. This is one of the most complicated configuration with envelope and cartoning unit. This spans 4.5 meters, so the output per square meter is the highest in the market. So this allows also for a very interesting man-to-machine ratio. And so one single operator can look after, theoretically, multiple lines.
All right, thank you. We have one more question, and it reads, what are you doing in terms of sustainability?
Oh, we're doing quite a lot because here we've developed capabilities of running these very interesting filter materials. So this is PLA-based woven, non-woven, fully compostable, and also the top and tail feature that I showed you earlier is actually allowing for shortening the stack, hence the length of the box, so we're going to use less cardboard. So it's by definition, let's say, very sustainable.
Okay, well, thank you very much, Stefano Fiordalisi, for being with us this morning. Ladies and gentlemen, that's it for this session, but stay with us as the next one will start in just a few minutes. See you later.